Welcome to EDU World Space.
Alright guys, we're doing problem 106, chapter 9, chemistry central science. So it wants to place the molecules and ions in orders from largest to smallest bond order. So remember, bond order, you can think of a single bond has a bond order of 1, double bond has a bond order of 2, triple bond has a bond order of 3, etc. etc. And also, if you have a single bond, then a partial double bond character, then your bond order is going to be between 1 and 2. And if you have a double bond, partial triple bond character, your bond is going to be between 2 and 3. So first, when we look at these molecules, we have to count the number of valence electrons because that's going to affect it. So let's look. So first, let's draw our stable molecules. So B, S, S, H. Let's start with the ions. Draw what our just ground state ions are going to look like. Now we're going to take away one electron, which is one electron that's going to be taken away from our bond. So there's only one bond here that's composed of 2 electrons. So that means that these are going to share one electron. So we're going to have a partial double bond character. And now we're going to take an electron out of here. And then for this one, now for this, now we can find the relative bond order based on this. So since this one has a partial character, it's not going to have a single bond. It's going to be, your bond order is going to be between 0 and 1. For this one, our bond order is going to be between 2 and 3. And for this one, our bond order is going to be between 0 and 1. Now, let's go look at the others. So we're going to look at our boron. So boron has 6 electrons. So we're going to make our bond here and have these lone pairs over here. So we have 6 valence electrons in total. This is going to have a bond order of 1. Now for neon, it's going to be a bit more complicated. So let's assume our neon has one single bond. Now we have 16 valence electrons in our neon, so let's see how many we have here. We have 2, 4, 6, 8, 10, 12, 14 here. So we're missing 2 electrons. We try to put the bond here, but then we're violating our octet rule because then neon's going to be surrounded by 10 electrons. So we could try putting a lone pair here or here, but then again you have the issue where you're going to be surrounded by more than 8 electrons on either on either molecule. So it's very simple. This bond does not exist. Yes, there's no way to create this bond without without breaking our octet rule. So our bond order is going to be 0. Now, let's order this. So Ne2 is going to have the least bond order. Then we're going to follow by either our hydrogen or our fluorine. So hydrogen and fluorine both have a bond order of between 0 and 1. Now, let's look at the atomic radius of our hydrogen and the atomic radius of our fluorine. So hydrogen's atomic radius that's going to be that's going to be 0.53. 0.53 angstroms. Now for fluorine, it's going to be 1.47. So now in diatomic elements, we can approximately say that so let's say we're dealing with a complete single bond. And so the sum of the atomic radii of our atoms creates the length of our bond. So, so for LH, that's going to be 2 times 0.53. That's going to be 1.06 angstroms. And for fluorine, that's going to be 2 times 1.47. Now it's going to be 2.94 angstroms. So since the bond length ideally would be so the bond length for a neutral F2 and is going to be greater than neutral H2, which means that our hydrogen is going to have a stronger bond, because it's just the fact that our atoms are closer, so they can interact more easily, as opposed to fluorine, which has a longer bond length. The longer your bond length, that tends to be weaker. Like, think about it this way. It's easier to break a long stick than it is to break a very short one. So we can assume that when we take out an electron, it affects the bond to the same degree. So we can say that fluorine is going to be weaker. F2 plus is going to be weaker than H2 plus. Next, we follow this by a boron by B2, which has bond order of 1, followed by N2, which has a bond order between 2 and 3. And we can so we know we can find the bond order. So to find the bond order, or rather to estimate the bond order, we have to write down the Lewis structure of our atoms. And remember, bond order of 1 is a single bond, bond order of 2 is double, bond order of 3 is triple. And we have to to find the bond order of ions, we're going to be taking electrons away from the central bonds, because we're taking one electron away. That's going to mean that they're going to be sharing a bond that only has one electron, which is significantly weaker than your normal bond. That's only going to be a partial character. because because conventionally, when we talk about covalent bonding, we have as molecules that are connected by 2 electrons. So if we have 1 electron, that bond becomes significantly less stable, so the bond order is going to decrease. You can think of bond order as just a degree at the degree to which your bond, the strength of your bond, basically. That's what bond order is. So when we do these kind of problems, we develop the neutral structure, we count the number of valence electrons, because the valence electrons are the only ones involved in bonding. We have to obey our octet rules like we did it in neon, which has no interaction. And then we can talk about how getting rid of electrons can affect our bond.